1,000 feet of chain link fence is to be used to construct 6 animal cages as shown in the figure. Find the dimensions that maximize the enclosed area. Well, we know that area is equal to length times width, that is x times y, using the notation in the figure. We also know that 1,000 feet of fence are available, but that we've already used up 3x of them here. And so in order to determine how much is left to make each of these vertical segments, we're going to have to take that 1,000 minus 3x and divide it into 4 equal pieces. That will give us an idea of how much fence can be used for each of the 4 pieces that are y units, y feet long. Simplifying that gives us 250 minus 3/4 x. So now we have an expression for y in terms of x, and we can go back to our area function and get an area function that is only expressed in terms of x. We have x times y, but we have an expression for y that's 1,000 minus 3x over 4, and of course we simplified that to x times 250 minus 3/4 x. And we are supposed to find the dimensions that maximize the area. Well, this is a parabola, or it's a graph. The graph of this quadratic will be a parabola, and we can see that it's going to open upward if we distribute the x through. We're going to see here a negative 3/4 x squared. So the lead coefficient of the x squared term will be negative, and the parabola will have a shape something like this. That means it's going to open downward and will have a maximum value, and that maximum value occurs at the x-coordinate of the axis of symmetry. Another way to find that is to find the point halfway between the two x-intercepts. So let's go ahead and do that. If we find the x-intercepts, we do that by setting a equal to 0 and solving for x. Let me finish this graph up. I want to make sure that I label these axes carefully. This is the x-axis, and this is the a-axis, where the vertical axis represents the area of the pen. So I'm looking for places where the area is 0. That happens when either x equals 0 from this term. That turned into a not equals. I want equals 0. Or where 250 minus 3/4 x equals 0. Well, we can do some work to further solve that. That's 250 equals 3/4 x, and to solve, we'll multiply both sides by 4/3. 3/4 times 4/3 is 1, leaving just the x. And 4/3 times 250 is 1,000 over 3. That's equal to x. X equals 0 is our other root. If you want to get an estimate for 1,000 over 3, that's, what, 333 1/3. And we're actually interested in the point halfway in between those two roots. There's 0. This is going to be the 333 1/3. Halfway in between, we can get that by adding the two together and dividing by 2. Of course, adding 0 to 1,000 thirds isn't going to change anything, so dividing by 2 is going to give us 1,000 over 6. That's going to be the axis of symmetry for that parabola. It is also, if we compute a at 1,000 over 6, it will give the max value for the area. This is our x-coordinate. This is what we need x to be to maximize that area. In order to find y, we can compute the 1,000 minus 3x divided by 4, or we can use the simplified version here. Let me pop that up since the podcast is getting a bit long. Through the magic of pausing, I was able to compute the value of y. There's the work. If you want to follow that through, you can pause it here and have a look. You get y equals 125 feet. So the values that maximize the area are x equals 333 1/3 and y equals 125.